All right, before we start talking about perpendicular lines, we started with parallel lines the other day. Can someone remind me what parallel lines are?
Lines that never intersect no matter how far they go.
Okay, lines that never intersect, and what else can we add to that? Not necessarily. They have the same slope. So parallel lines have the same slope. Here we're going to talk about perpendicular lines. What do you know about perpendicular lines? They're going to intersect and create 90-degree angles. Do you know anything about their slopes? I bet you do, and you just are not thinking. They're the opposite. You have one of these words. They're opposite. There's another math word.
It does start with R?
It does start with an R. Reciprocal, nice.
Oh.
I'm going to tell you what reciprocal means. So, two perpendicular lines have opposite reciprocal slopes. So, for instance, if I give you a slope of 2/7, so that's the slope of one of your lines. Opposite of that would be negative, right? Because this one's positive. Reciprocal just means you flip that fraction. So it becomes 7/2. So these two slopes would be perpendicular. Okay, opposite is positive, negative. Reciprocal just means flip the fraction. What if I give you a slope of -3? What would be perpendicular to -3? Positive 1/3. Because remember, I can write -3/1 if I want to. It's the same thing. Why are we allowed to have, or why should we have that fraction there? Why is it important to have a fraction for slope? It gives you the rise and the run. You need both pieces, right? You have to be able to go up and down. Even if it's 0, you have to know whether you're going up and down, and then left and right. Okay? Take a second, and you can do it by yourself or with your group. I want you to find the perpendicular slopes to each of slopes A, B, and C. So, the perpendicular slope to 2/3 is? -3/2. The perpendicular slope to -1/7, positive 7/1. And the perpendicular slope to 4, -1/4. Okay? So far, so good? All right. We need to show that this figure here is a rectangle. So you kind of have to think back to Monday and the properties of quadrilaterals. What are some important things about a rectangle that you think we need to prove? Parallel lines. Okay, so what about parallel lines? Which lines would be parallel if it's a rectangle? The opposite lines would be parallel, right? So that would mean AB is parallel to DC, right? We have to figure that out. And what? What else?
The interior angles are all...
Oh, wait, hold on. This one, we have this parallel line. We have one more set of parallel lines. Which set of parallel lines? AD
and BC.
And BC need to be parallel. So those opposite sides have to be parallel. Is there anything else super important about a rectangle?
The interior angles are all 90 degrees.
All of the angles are 90 degrees. So how is that going to help us?
If we...
What creates 90-degree angles? Perpendicular lines, right? So if all of my lines are perpendicular, then we can say that all those angles are 90-degree angles. So for instance, we need to know that AB is perpendicular to BC. If we know that, we know this angle here is a right angle. So are we okay with that? Okay. We need to know BC is perpendicular to DC. So I'm just working my way around the figure. What else? What about DC would have to be perpendicular to what? AD. And then AD needs to be perpendicular to AB. Now this looks like a lot, but once you find the slope of one of the sides, you can just kind of fill it in everywhere else and we can compare. So either by yourself or with your group, take a second and determine what the slope is of each of these lines. So I would start with the parallel lines and then we can fill in the rest. Okay, so you can use the slope formula or you can count, up to you. All right, Adrian, can you tell me the slope of AB? What is the slope of AB?
AB, the slope is rise 3. Oh,
That's fine, rise 3.
1 6.
Okay, does that reduce at all?
Yeah, it reduces to 1.
Perfect. Christian, can you tell me the slope of DC? Mm-hmm.
It is 6-1 and rise 3.
Okay, so the rise is 3, this run is 6, which reduces to 1/2. Is AB parallel to DC? Why? Because they have the same slope, so we're good there. So let's do AD. Bella, slope of AD.
AD equals -2.
Okay, -2. I'm going to put it over 1 just so we have rise and run, but -2 is fine. And Josh, BC, slope of BC.
Is -2 over 1.
Okay. Are these two lines parallel? Yeah, they have the same slope. So far, we know that opposite sides are parallel, which is great, but that could mean it's a parallelogram. I mean, it obviously doesn't look like a square. You can tell that one side's longer than the other. But if this was shrunken down, it could be a square technically. So now we need to show that all of these sides are perpendicular. You've already found the slopes, so I'm just going to fill it in. I know AB is 1/2. I know DC is 1/2. I know BC is -2 over 1. And I know AD is -2 over 1. I don't have to find anything again. I'm just filling it in. And now I have to compare. Are these perpendicular slopes? Are they opposite reciprocals? Yes?
Yeah.
Yes? Yes? And yes. So all of those are perpendicular, which tells you this figure is a rectangle. Questions on that? Yeah.
What makes it like not a square? Like I know like obviously resolution is not a square, but if you did it
So really to prove that it's a rectangle versus a squares, we'd have to find the length of those sides using the distance formula, and we're not going in depth that much right now. If it was like half that size and it looked more like a square, we would have to do that. But it's over exaggerated for that reason because you know there's no way that's a square. Yeah.
Are we also gonna do congruencies?
Yes. Similarities, not necessarily congruence. Triangle. You're talking about triangle congruencies? We'll do triangle similarity. Okay. I want you to take a second. We need to show that it's a trapezoid, first of all. And we need to show it has 2 right angles. So take a second with your group and figure out, like we did up here, what it is that we need to show it's a trapezoid and it has 2 right angles. So I don't want you to do any math or find the slope. I want you to set up like these question mark things. So take a second with your group and do that. All right, I'm going to open this one up. Who can tell me what I need to find out? What do we need to know?
Angle L is equal to angle K. Do we need to find out?
We need to know about angle L and K. Let's start with how do we know it's a trapezoid? What do we have to prove to show it's a trapezoid? Which opposite sides need to be parallel? Okay, so we need to know JK is parallel to ML. Did we get that far? Oh, I see a lot of writing. Okay, you need to know those opposite sides are parallel. So that's that first part. Then we have to show that two angles are right angles. Gabriel said K and L. I agree that we need to show K and L are right angles. How would I do that? What creates right angles? Perpendicular lines. So what two lines create angle K? JK needs to be perpendicular to KL. And then what two lines create angle L? KL and LM. So let's find the slope of JK. So my rise is, what's your rise? 2. And my run? How about -6? Because we go backwards? Are we okay with that? Okay. Which reduces to -1/3. And we need to find ML. What's my rise for ML? So I go, okay, so you can go down 1 and over 3. Are JK and ML parallel?
Yes.
Yeah, they're the same slope. I already know JK is -1/3, and I already know ML is -1/3. So I just need to find KL. Take a second and find the slope of KL. What's my rise and my run for KL? 3/1. I go up 3/1. Are these lines perpendicular? Yeah, they have opposite reciprocal slopes, which means this is a trapezoid with two right angles. Questions on the front? Okay. We already talked about what the slope formula was. I think Lauren gave it to us earlier. Samantha, can you give it to me now? Do you remember what the slope formula is?
y2 minus y1 over x2 minus x1.
Perfect. y2 minus y1 over x2 minus x1. Let's find the slope of line A and line B. Okay, we'll just do it together. I'm going to label, so x1, y1, x2, y2. So line A is going to be -3 minus 5 over 1 minus a -1. -3 minus 5 is -8. And what happens here? Becomes positive, giving me 2, which means my slope is -4/1. Are we okay with that? Okay. For B, your formula is going to be 2 minus 3 over -2 minus 2. 2 minus 3 is -1. -2 minus 2, -4. Are you going to leave your slope as -1 over -4? What would it be? Positive 1/4, right? Because a negative divided by negative is a positive. So are these lines perpendicular? Yes. So how can you say that in a sentence using math terms? They're perpendicular because they have what?
They're reciprocal.
What's the word in front of it?
The opposite reciprocal.
So they're opposite reciprocal slopes. Okay, so yes, the lines are perpendicular because they have opposite reciprocal slopes. I want you to find the slopes for 2, 3, 4, and 5, and then check with your group. So for WX, you should have 6 minus 7 over 5 minus 2, which means your slope is negative 1 over 3. For XY, negative 4 minus 6 over 5 minus 5. So you have negative 10 over 0. Did you leave it like that? No? What'd you put? Undefined. Remember, if 0's on the bottom, it's undefined. If 0's on top, it's 0. If you can't remember, plug it into a calculator, and one will have error, one will say 0. Y minus z, yz, negative 4 minus a negative 2 over 5 minus a negative 1. So that becomes a negative 2 over 6, which reduces to negative 1/3. And lastly, ZW, you should have 7 minus a negative 2 over 2 minus a negative 1, which becomes 9 over 3, or 3 over 1. Are we okay with all those slopes? So is figure WXYZ a rectangle? No? Can someone explain to me in words why it is not a rectangle?
The undefined angle, undefined.
What does an undefined line look like? It's
It's everything.
I know the answer. I'm just waiting for someone to be confident in their answer.
It's everything yet nothing.
You're confident it's a horizontal line? So what's the rise on a You can't switch it on me in the middle.
It's vertical because we have vertical.
It's horizontal. It's towards a straight line.
99%. Ay. Okay. You're confident in vertical. It is a vertical line. So let's think about it. So 10 over 0. This is your rise. So if I start here and it tells me to go up 10 and then over 0, I have a vertical line. If it's 0 over 10 and I start here, I go up 0, but I go over 10, which gives me my horizontal line. Okay, so you have a vertical line. You can have a rectangle that has a vertical line. So that being an undefined slope doesn't necessarily prove that it's not a rectangle, but you can use that information to show it's not a rectangle. How did we prove rectangles on the other side? Okay, so we showed that all the sides were perpendicular to each other and opposite sides were parallel. Are all the opposite sides on this parallel? These two are, right? These are opposite sides. Those are parallel. Are these parallel? No, they don't have the same slope. Do you see that? So it's not a rectangle because opposite sides are not parallel. Not a rectangle. Because the opposite sides are not parallel. You could have also said that the like the two sides next to each other are not perpendicular, which doesn't give you right angles. So there's multiple ways you can explain some of these. Find the slope of line L. It's on a coordinate plane, but it does not give you points. Can someone give me 2 points that would help me easily find the slope of line L? 0, 3. Okay, that's 1. 2, 0. So what's my rise? 3, and the run? 2. -2. Thank you. Because we went backwards. How did we find the slope? Rise over run. Line T is perpendicular to line L and passes through point K. Find the slope of line T. So if it's perpendicular to this line here, what will the slope be? Positive 2/3. Because opposite makes it positive, and then you flip the fraction. So if we have point K, which is already on your graph, and my new slope is 2/3, up 2/3, you can draw in the perpendicular line.